Hello everyone. So this is Dinesh Kumar. In this video, we are going to learn about the heat transfers. How heat can transfer from one body to another body. In what are the possible ways it can transfer. This is what we are going to understand in this video. So this is the context of this video. So before discussing about these things, so that the people were thought that the heat is a kind of fluid. So whenever this fluid is transferring from one body to another body, the temperatures of those bodies may subject to change. Like that they believed. So this idea is called as actually caloric theory of heat. But it was Joule who had disproved this idea by saying that heat is also kind of energy, just like the potential energy, kinetic energy. Heat is also kind of energy. We can able to convert the one form of energy into another. The same way we can also convert this heat into the another form of energies too. And we will try to understand the working mechanisms of conductions and convections and radiations. In conductions, the conduction will take place predominantly in solids. The reason why the conduction is taking place predominantly in solid is because in solids the molecules are very tightly packed. The interspace between the molecules are very less in the solid. So in that case, the molecules are having less freedom to move. They cannot move from its equilibrium positions. They are very rigidly, tightly locked in atomic points. They can able to vibrate about its equilibrium positions, but molecules cannot move from its equilibrium positions as a whole. So that's why the solids are having the rigid shape. I hope that you know that, right? You can always correlate the average kinetic energy with the temperature. So in order to understand these things, let's say that we are having objects in that all the molecules of the objects are moving very violently, very fastly. Let's say assume that they are having such a jiggling and wiggling motions. So then we can say that the average kinetic energy of the molecule is somewhat more. So the average kinetic, the temperature is nothing but it is the measure of this average kinetic energy through some instruments. So then obviously if your object is having more average kinetic energy, then we can say that the temperature of the body is somewhat more. The same way, if the average kinetic energy of the body is somewhat less, then we can say that the temperature of the body is somewhat less. You can able to understand that in that way. So there is some intimate correlation between the average kinetic energy and then temperature. In fact, the temperature is nothing but it is a measure of average kinetic energy. So the molecule, the solid molecule, even though they may look like a static, the object may look like a static in appearance, but the molecules of the solid may have the perpetual vibrations. So the temperature is the measure of the average kinetic energy possessed by those molecules. So that's the thing. Now let's assume that we are having a rod. Okay, I'm going to heat the one end of the rod. So if I'm heating the one end, the average kinetic energy of heat is nothing but it is the offering the kinetic energy to the system. So whenever I'm heating something, I'm indirectly adding the kinetic energy to the system. So let's say that if I'm having the rod, I'm going to heat the one end of the rod. Obviously, I'm pouring the kinetic energy into the rod. So obviously, the molecules of the rod will now started to move very violently. So as I have already told you that the temperature is the measure of average kinetic energy, right? So in that case, the temperature of the one end will be increasing. Now let's assume that I'm going to cut off the heat supply. So after some time, you know what would happen, right? So even though at the start the temperature at the one end is more than the another end, the heat will transfer from the higher temperature to lower temperature, and sooner the entire body will reach the same temperature. So that would happen because of the diffusions of the kinetic energy. So if you are looking at the atomic structure and molecules, so let's assume that this is the heated end. So this heated end, the molecules will be moving very violently, and nearby that end, the molecules are moving very slowly. So if the fast moving molecules are located nearby the slow moving molecules, there is a chance that they may collide with each other, they may impart its momentum. So if that happen, the kinetic energy will get transferred all over the bodies. So this is how the in conductions the heat transfers are taking place. But the important point you should note that is in conductions no molecules are moving as a whole from its equilibrium positions. All the molecules are located in its exact locations, but they are just vibrating about its equilibrium positions. While they are vibrating, they are imparting its momentum, so they are transferring the energy to the neighboring molecules. So in that way only the energy is got transferred from one molecule to another molecule. So this is why the conduction is also called as it is the heat diffusion process. So the same way the another mode of heat transfer is called as convections. In convection mode of heat transfers, so in addition to this heat diffusions, we'll be having the advections. Advection in the sense there will be some bulk motions of fluids. So it may be air or maybe a liquids. We will call both of these as a fluids since they are having the tendency to flow. So we are calling them as a fluids. So in addition to microscopic diffusions of the kinetic energy, if there is the bulk motions of molecules from one place to another place, it will enhance the heat transfer. So we call the combined effect of the diffusions and advections as a convections. The convections happen predominantly in liquids and gases. The same way, there is a third mode of heat transfer. It is called as radiations. The radiation for radiation to take place, we don't need any kind of medium. By the word radiations, we are saying that electromagnetic wave. It is obvious fact that for the electromagnetic waves to travel, we don't need any kind of medium to be there. So the electromagnetic waves can travel in even in empty space, which means you can imagine the radiation transfer, the radiation type of heat transfer in the following way: that in sun we are having so many atoms and electrons and protons, right? So because of that high temperature, the electrons on the sun will be vibrating very violently. So if the free electrons of the sun is vibrating very violently, so the electrons are having the field associated with it. So if the electron is located here, from the electron in all the possible directions there would be a presence of electric field. So suppose if the electron is vibrating very fastly, then it will generate a waves on this electric field. So we call these waves as a electromagnetic wave. So whenever these electromagnetic waves are passing the earth, so it can make the electrons in the earth to vibrate in the same frequency as that of that electromagnetic waves. So this is how in radiation heat transfers, the heat energy is being conveyed from one location to another locations, even though these two locations are completely separated by the empty spaces. So I hope that you would like these videos. If you're having any doubts on that, you just let me know that.